Hello and welcome to the new data science tutorial project where I will be showing you the end-to-end project. So we will start with the data import, data verification, cleaning, exploration, standardization of data. After that, machine learning. We will apply a different type of machine learning and I will give you some tasks here. Also, I will give you some tasks here for your homework so that you can easily do your all the practice along with me. And then we will do, based on the machine learning, we will do some predictions. Also, finally, what I will show you some real-time prediction. That means suppose you are taking this model and putting into some sort of application like a web application or desktop application or anywhere, then generally how would you accept the input? I will show you an example of that and make a prediction so that you can give the information out. That means you can actually create some real life application if you follow this procedure or if you follow this. The only thing which I won't show you is the development of application, because that's something out of this scope. The web application, if you want to know how to create some sort of a web application, I have produced two different courses. One on the Shiny, which is related to the R programming, if you are there in the R programming, and another is related to the Dash. So Dash is basically a framework where you can create dashboards and applications for this. So you can check out those courses. I will probably go ahead and put the link in the description. But mainly what I will show you, how would you basically do this type of an end-to-end project, which basically is needed from anyone who is learning the data science. All right, with that, let's first do thing is what data we were going to import. So wine quality is basically the data, which is a data that is related to checking about the wine quality. So a number has been given to a wine, type of a wine that is, and what is the quality. So think about this. If you are in a company, right, which is a wine making company, right? Like for example, in India, in Nasik, you have this Sula wine company. Suppose you work in a Sula wine company and right now company is spending the hundreds of thousand rupees or millions of rupees in terms of wine tasting, right, and checking whether wine quality is good or not. So you have, let's say, 100 people out there who are tasting hundreds or thousands of different wines that probably they are making every month, right, and basically giving the feedback and things like those. So you want to automate this entire process, and with the help of the algorithm, with the help of the machine, you may want to optimize this entire process so that you are not waiting up until the wine taster, that the wine is finally made or a sample is made and they are testing and doing it. But with the help of the machine, you want to be accurate enough, like 90% and more, that your wine is actually good or not, right? So in that case, if this is something, a project that is coming to us, then we can utilize how we can do this is something with what I will show you. So similar type of use case you can solve with the help of this basically process. All right, so first thing first, we will going to import the data, and the data is present here. And as you can see, I'm using the Colab, right, Google Colab. That means this will be a live workbook. You can go ahead and access it using the link which I have given in the description. And along with that, you have the dataset link as well. So with that, first thing first, we were going to upload the wine quality. This is the dataset, wine quality N, and I will click upload. Click OK. So this is something which you will going to have, and if you see on the left hand side over here, the wine quality is present. So we will going to import couple of standard libraries like pandas, numpy, matplotlib, and seaborn, which is data exploration, data import, data visualization library. Rest other libraries I will import as and when the need is arising. so that you will get to know that when to import which library, right? Sometimes when you see an actual program, there are like 15 or 20 different libraries that are there. And when I started learning back in the day, that was also quite daunting. It's like, where would I use all of these libraries, and what is the use exactly where is it being used? So keeping that in mind, the struggle which I had around 5-6 years back when I started doing this space, this is something I want to make it simple for you, and I want to give you the exposure to the library only when it is needed, right? So with that, let's first get our favorite pandas. Import the numpy as np, the alias, import seaborn as sns, and matplotlib.pyplot as plt. So all of this libraries, this will help us do the data import as well as some of the data exploration tasks, even some in certain cases visualization as well. NumPy is basically to convert the data into array when we will going to do some sort of a prediction on the real data. Then we have the seaborn library like seaborn as SNS, and which is also a data visualization library, and matplotlib is also a visualization library. Matplotlib is basically the base visualization library. On top of that, you have the seaborn, which have some more advanced features. With that, we will going to, and before that, I will also import warnings library, so that if any warning is coming, let's say if it is an old feature or feature is about to obsolete, so those type of warning, if you want to filter that, we can use with the help of this command, warnings.filter warnings, and within bracket we say ignore. That way unnecessarily a lot of long warnings will not come. But if you are really interested in seeing the warning, then you can remove that from here. Okay, so after that, first thing first, let's create a data frame object where we will going to store the wine quality and .csv, and we were going to enter that. And now no search. Okay, just make sure that wine is properly written there, and I hope nothing will be problematic now. Okay, once we are done, let's just check the first few rows. Wine.head, right? So it shows the first 5 rows, right? Here in this case, all of them are white wine. If you want to check the last rows, wine.tail is something you can do, where you will see the last couple of rows. So it is going all the way up to 6496. So that's something we can check, that starting from 0 to 6496. That means 6497 rows are present. Although we can also use this method, which is wine.shape. It will also give the same output, that you have 6497 rows. So starting from 0 to 6496 is actually the 6497, and you have 13 column here, starting this from type to all the way till quality. So you have 13 columns over there. So second, now another important thing is checking the null in each column. So wine dot is null dot sum. Sorry, this has to be bracket. So here you check, you get that fixed acidity column is having the some nulls like 10 values, 8 values, 3, 2, 2. So it's like very minimal values which are null. And generally over here also pH has 9 and surface has 4. So two things can be done over here. One is either we remove it or we basically impute it. So in this case, since they are like very less, we can remove this. So we have that wine dot drop, let's go, no, okay, drop NA, and after that I will, let's just see whether it drops everything or not. 6463 rows Is it the same thing now what is coming over here? No. So what we need to make sure is we say in place equals to true. So now it is fine, and now you will see that 6497 will change. 6463. That means all of these rows are removed. If we run this code again, you will see all of them are 0000. So it is important that you don't have any missing values, so that you will not have any issue when you are doing the machine learning, right? Another method which I want to show you is something, if you want to fit averages over there, then what you can do is you can simply run this command, wine.update, wine.fill_any, right? So you are updating the wine object and you are filling the any with what? Wine.mean. So that way you will going to fill the averages over there. So I will just keep it over there. Since we have already done this, drop the NAs, but this is where if you want to fill the averages, then this is what you are going to use, right? Okay, so after that, now let's just check that how many red and white wines are present, just for the sake of checking. All right, so we will say wine type and dot value underscore counts. So once we do that, what you get is we have 4870 and 1593. What if I want to check the percentage, because that is much easy to interpret? Well, in that case, in value count you come, okay, not here but here, normalize equals to true. So 75% of the values is what you have for white wine. For red wine you have this. Similarly, what you do is you check the quality variable. Okay, that's an exercise for you. All right, and if you want to visualize this information also, so you can plot it using, let's say, SNS library, sns.countPlot x equals to type, right, and data equals to wine. This will going to give us that white wine is high, red wine is low. This is what it is also indicating by these numbers. So that's something what we can do. Now what another important thing we generally want to understand is the distribution of these data points, right? So what I'll do is I will show you the distribution of fixed acidity, and as well as if there is any outlier is present or not, and you need to check with every column up until alcohol. That way you will going to repeat the code which I'm writing here right now. That is an homework for you. So first thing first, we were going to plot two visualizations. So we will say PLT. PLT is nothing but this matplotlib.pyplot, just to create a connection there. PLT dot figure, we want two figures, and PLT dot subplot 1 to 1. That means one row, two column, and first figure. That is what it means. After that you have SNS, so distribution plot, distplot, DIST, distplot, and we will say we want the fixed acidity, right? So what do we know? Fixed acidity. So that's done. Now we will say PLT dot subplot 1 to 2, and here we need a box plot. So we'll write a slightly different code. Wine, come, yeah, there you go, fixed acidity, right? Wine fixed acidity dot plot dot box, and let's make it little bit big. Fig size equals to 15,5. So slightly bigger visualization than what it will give. Okay, so two figures. This is the first figure. This is what it should plot. This is the second figure plot, and this is what you should plot. Let's execute. And there you go. So we have this slightly right skewed distribution and a lot of outliers over here. So, and some outliers even on the lower side, and its average is close to somewhere 7. So it basically gives you an idea as to the data, what you are dealing with. That way it is easy for you when you are interpreting it, or you are basically putting a documentation together as to what are some of those variables which may influence a lot. Like in this case, these outliers may influence this, and maybe some treatment you may want to do after producing the first basic model, right? So that's something now you need to do on each variable. I have shown you on the fixed acidity, but do it in each variable and interpret it. All right, once we are done with this, which is a single variable analysis on the fixed acidity, I now want you to do the bivariate analysis, which means it will involve two variables. So for that, I will going to basically plot the quality of wine against all the different variables. That means I will show you one variable and you need to do it for all the others. So for this, we will say, I will create a slightly bigger figure so that it is easy. Fixed size, it's the same code. If you would observe, if you will write it like 10 times, you will be an expert. And that's why I want you to do this homework. So plt.figure, fixed size is 10.7, sns.bar plot. So we'll create a bar plot where first variable, x variable, is nothing but quality. The y variable is nothing but, let's say, fixed acidity in this case. So fixed acidity, and we have data equals to wine. Oh, it should not be warnings. Wine, and we execute this, and it is going to produce us the quality for different types of fixed acidities. So clearly, wine number 7, 8, and 9 is where you have the good quality, and the wine number 9 is showing some variation with the help of this error bar. So that's something you need to produce. Now check each of the other variable. First variable will be the same quality, and all the other variables will be plotted against it on the y-axis to check where quality is high, where quality is low. It will give you a good idea about each of these variables and how the quality of the wine is attached to each variable. Now if you have this, I will show you one very quick way of plotting all the variables against each other, and that is nothing but your scatter plot and your histogram. So like the one histogram which we have plotted here, this one, we are going to plot it for each variable. Now, so sns.pairplot, just one simple command, and if I execute this wine, you will see a plot that is basically for each and every variable. And while it is plotting, let me take a sip of my tea. Nice tea. So yeah, that's the best thing. Sometimes when your code is running for you, you can actually take a sip of your coffee or your tea. Like I'm part of this world where in India you have this tea, but if you are sitting in, let's say, US, where coffee is more famous, then enjoy your coffee while this code is running. So you can see it is doing a lot of processing out there, and hopefully it should give the output soon. So my second sip is done. Let's see whether it can produce. So it depends on another thing, like a lot of different things, like your laptop, your internet connection, and obviously how big the data is and the capacity on which you are running. So capacity, I think, is not an issue. All right, so now you have the output. As you can see, how complex and big output is being produced here by just one simple command. So you can see a lot of things have been were basically working in the backend, and you can see each variable is here, in cross section is here, and scatter plot is basically showing whether there is a positive correlation or like no correlation at all. So it's like a chart where you can actually spend hours writing your observations. Similarly, if you see this one, you see that different types of histograms that's basically it has produced for you. So I wanted to show you how you can do it by using just one single command. Okay. Now what we want to do next is correlation. So we want to check each and every variable's correlation. So with that, a simple command is wine.core. So what it will do again, it will produce the correlation for each and every variable, and this will basically going to help you understand whether there is a negative correlation like between fixed acidity and total sulfur oxide, or there is a positive correlation like this one, very high, sulfur dioxide and total sulfur dioxide, a very high correlation. But sometimes these values are very difficult to interpret because you have to go one by one to each number. Instead, a better way is plotting it as a heat map, right? So again, let's say we create one more figure and a big figure. So fixed size equals to 15, 10, and we create a heat map using the SNS. So heat map, we will say simply wine.core and cmap equals to cool warm. And now it will going to produce this plot. So this plot is basically telling you the similar thing. For example, its correlation here, positive correlation. This is negative correlation and this is the positive correlation, and the highest positive correlation is over here as we had experienced with the free sulfur oxide and total sulfur oxide. Similarly, total sulfur oxide here and free, so it's like the same. Second is this is a positive correlation, this is where some positive correlation, this is where some positive correlation, and these two blue, density and alcohol, and here you are seeing a good strong negative correlation. So what generally we do is if there are a very highly correlated values that tends to influence the model, we basically remove it. So what if you want to remove any particular one, let's say for example we are seeing this one which is high 0.72, and another is basically the negative one which is alcohol density, and yes, alcohol density. So you have alcohol here and density here minus 0.68. So let's say we remove anything which is 72, like more than 0.7. So in that case we will basically going to write a simple drop command. We want to remove the total sulfur dioxide. So we will say wine_new and wine.drop. What do we want to drop is the total sulfur dioxide. So total sulfur dioxide, we'll say axis equals to 1. Alright, so we have this wine_new dot head, and now sulfur dioxide, as you can see, you have only free sulfur oxide but not the total sulfur dioxide. Another thing we may want to do is this, converting the white and red wine into 0 and 1 categorical variables so that it can be used there in the model. So we will create an ML data set now. So wine_ml, and we will say using the pandas pd dot get dummies. So get_dummies, and here we will pass the dataset name wine underscore new and drop underscore first is equals to true. So what it will do is basically going to convert this data set. So wine underscore ml dot head will now have everything as same, right? And the type column is now changed to type white. If it is white, 1, otherwise if it is red, then it will be 0. And that's the reason we don't want the another variable like type underscore red, because it basically shows the opposite same information. However, all of the information that you need is present here in the one column itself. All right, so once we have this, what we can what we may want to do is just double check whether it has still any null. So wine ml dot is null dot sum, otherwise it may give us errors. Okay, all good. So that means we don't have to really worry about that. Now the next thing will be for this quality variable that you are seeing over here, it's something if let's say we decide a categorization, anything above 5 is good, anything above less than 5 is bad. Or if you go slightly higher, like anything greater than 8 is good, or anything greater than 7 is good, below 7 is not good. So that's something we need to code. So here, with the help of this command, what I am creating is basically a y variable here. So we say wine underscore ml, and we have quality, and we are going to use the apply function. Within that, we will going to use lambda for quickly converting this, and we will say y colon and 1, that means coded 1 if this value is greater than 7, right? So y is nothing but the quality has been moved into the y. That means here interpret or read it as if quality is greater than 7, then it will be 1, this else 0. Simple, right? So if I just go ahead and do that, print it afterwards, so you will see that y values are now 1 or 0. Okay, so once we are done with this, what we may probably need to do is, as you can see, the fixed acidity value is quite high when you compare it to the volatile acidity. Even the sugar value is high when you compare it with these decimal values. So we may need to standardize this data set so that these high values like this one, or like alcohol, or like dioxide, is not basically influencing the model. So the way we will going to do is using the standard scalar. So from sklearn dot pre-processing, we will going to import the standard scalar. Okay, after that we will going to initialize the standard scalar. We will need to create an object by initializing it, standard scalar, and after that we fit scalar dot fit. So we need to fit the x variable over here. X is nothing but your this data set wine underscore ml, but wine underscore ml also has the quality variable, which is actually the y variable. So what I will do is, from here I have entered inside this cell, I will press escape and press A. This will create a cell over here. So X I will create over here, and I will just simply say that over here is wine underscore ml dot drop, and drop what? Quality, and axis equals to 1. Okay, so this is now created. You will see that quality variable is dropped because quality is actually the y variable which is already stored there. So now we can fit the x variable over here, and after that we say that x underscore standard equals to, we need to transform now. So this is a part of these steps that we need to take. We need to first import the library like we have done, standard scalar. After that, we initialize the model, like in this case standard scalar. We need to fit the model and then we need to run the transformation. So that's basically step 1, 2, 3, 4. Every time you will perform the same steps. Okay, so once you are done, you will execute this, and that way your values, okay, transform. So that way your values will be transformed properly. So once your values are transformed, if you want to somehow see this, x underscore standard, let me just see whether it will show here. Okay, because it has converted into an array, but I'll just execute this. You will see that every value is basically being transformed. There is a calculation which has run behind, and it has completely transformed the original values into a standard values, which will be basically, I think, between 1 to -1 if I'm not wrong. Right, so but in some cases it is -1.74. That means it's actually not the same like the fixed acidity over here and sulfur dioxide. But if you still want to know what's going on here, you can always check this SQL Standard Scalar, and this will basically help you that this is the calculation. This is a z-score which is being so the standard score of sample x is being calculated like x minus mu, which is nothing but the mean. As you can see, mu is the mean and s is the standard deviation. S is the standard deviation of this training. So this is basically a complete documentation. It has, as you can see, some attributes which you can set. So this is something far more advanced, which is basically over there, but gives you a good idea as to what's going on here and what is the calculation, because this is something it may come in your interview as well, like what's go inside in the standard scalar. And here it basically standardized values by removing the mean and scaling to unit variance, and the calculation is with the help of this. All right, so with that, this is what going on in the background of the transformation. Once it is done, we need to create a test and train data set. So what I will probably do is I will just create again the x variable and keep all of the x standard value inside x, so that it's easy for me to create a train test split. So I will going to import the train test split by using this command, that from sklearn dot model underscore selection import train underscore test underscore split. Once it is done, I will going to write x train comma x test y train y test, because this will require when we will going to run the machine learning algorithms, and using the train test split x comma y. So x is this, y is this, right? We will going to write test underscore size, let's say 0.2. That means 20% of the observation should come in the test. So training will use to train the model so that model can understand what the different observation is, and it can understand the properties for prediction. And testing is to really test the model against the training data. And if you want to repeat the exact output, just say random underscore state and provide any value like 245, any value. But once you will write 245 again, it will produce the same output. Or if you are going along with me, then this you and I will going to have the same output. Okay, so this is this, and now we have this. After that, we will going to first run the very famous logistic regression. So sklearn dot linear underscore model import logistic regression. Okay, so we execute that and we will initialize the model like we have done in the case of standard scalar as well. So log reg equals to logistic regression. Once we initialize this, we need to fit the model same way we have done here, if you remember. So log reg dot fit on training values x train, y train, right? Once you are done with this, you execute it. Okay, now the model is being fit. What we will going to do is predict the value. So y underscore pred, predicted values. Predicted values will be based on this log reg model we fitted dot predict. Prediction will be based on test value x underscore test. So this is the test values against which it will be predicted, and we will validate the output against here test data set. So y underscore pred is something what we are creating. Now we will going to validate whether this predicted values is same as test value, because what happens is x train and y train will have one data set, x test and y test will have another data set. We have predicted the value based on the y test. Now it's like we basically put y pred and y test side by side and check whether they are same or not, right? So that will give us an accuracy score. So we have this metric from sklearn dot metrics. We have to import accuracy score. So accuracy underscore score. There is another one which is to produce the classification report, and there is that one which is confusion metrics. Generally, these are the three high-level metrics what we produce. There are others as well, like AUC score and all. So something I will probably keep it for later, but for a beginner, I think if you understand this, you can move on to the next step. So maybe in my future videos, I will keep on increasing the this piece so that step by step one can very easily learn. All right, so first thing first, let's have the accuracy score between the y test and y pred. So first we need to provide the true value. True value is nothing but the actual value, test value, and then the predicted value. So y underscore test, y underscore pred, execute, and 97% accuracy by just running a model within 30 minutes. That means that's a very huge or high level accuracy. And generally we don't stop here. We basically have to evaluate entirely this data against a couple of models, because generally what happens is some model try to overfit and we may need to basically see some realistics. What is realistic is a different debatable issue, but it is about which model is working best by testing multiple observation and then basically seeing where the model is not working fine, and we need to be aware about those scenarios. Okay, so we have this. Now we can print the classification report as well. This will also take the attribute, as you can see, y true, that means the y test and y pred. Y test and y underscore pred. When it produces a big report like this one, it has various different types of metrics like the precision, recall, F1 score, and support. And you can read about that using the same documentation, because that's, again, if I start explaining and interpreting this, it will be a 2-hour long video. So something you can do it, take it as a homework and read about what is precision, what is recall, what is F1 score, and how does they indicate. Generally, a rule of thumb is in some of the metrics, for example, F1 score, higher the F1 score, that means if it is near to 1, the model is very good. So 0.99 indicate that we are doing really good with our model, or so far the processing that we have done. Okay, so with that, what we can do is we have this confusion metric as well. So we can print the confusion metrics as well, and it will also going to take the y test and y pred. and that's basically a confusion metric. Again, a different metric where you have 4 different metrics like true positive, false positive, and I think 2 more. So it's quite confusing as well sometimes, but something very important where you will also find that precision recall and everything is being repeated over there. So something you may want to read about it and take a note about what each of these numbers really mean. But just want to keep it a little bit out of scope. Don't want to make it a very, very lengthy video because this is all about reading, interpreting, and understanding what each metric is. Okay, and maybe what I'll do is create a separate video. I think I mentioned in the previous videos as well. So I'll find some time and create a video on both of these 2 reports so that I can refer you to those videos. You can easily understand this piece. Okay, once we have done that, another important thing is, which user usually ask is what are the important variables that is influencing the model? And for that, we have models like random forest or model like XGBoost, which provide us this visibility. So what I want you to do is, since we have run the logistic regression, I want you to run the decision tree, right? And I want you to run the XGBoost. I will show you how you can run the random forest. The same way you need to run the XGBoost. That means 2 I'm showing you here, 2 you need to do at homework. Decision tree is homework and XGBoost is homework. Okay, so I will show you the random forest. So sklearn.ensemble, we need to import the random forest classifier, right? And we can initialize the model random forest classifier, and we fit. It's the same step. That's what it makes it interesting. But what makes it complex is this. Right now we are leaving this blank. This is something where a lot of parameters are present, and generally in real life or real projects which you will do it on a very messy data or something which is not producing good output, you start tuning the parameters. I will take some of that data set and produce, maybe in one of my future video I can take that out. So fit what? x_train, y_train, right? So we execute this and we say rfc_pred, and we say rfc.predict based on test values. So x_test. Now we run the same thing, accuracy score. Let's just see the accuracy score. Go ahead and print the classification report and confusion metric. So accuracy_score, y_test, y_pred. Okay, 97, similar output, 97061. Wow, it's exactly same. This is amazing, right? You know why? Because I'm using ypred, not rfc_pred. rfc_pred. So I was using the output of logistic regression model. That's why it was exactly same. Okay, so some better accuracy. You can see 97.98. That means almost 98%. So this is 97% accuracy. With this model, you got 1% more. What else you need? Like you are 98% correct. And if you want to find the important features, then what you need to run is basically RFC, the model, dot feature underscore importance. This method will going to give you the array, something you can't interpret, right? So what I'm going to show you a code, very, very important. So make sure you take a note of it, is how you can visualize all this. So we will say pd.series rfc.feature underscore importance, and we will say index equals to, we had this this object, if you remember, where we dropped the quality. Yeah, wine underscore ml drop quality, which was x, but x is something we have transformed, right? So we will say here wine underscore ml dot drop. We will drop the quality because it has to be only those variables which have contributed into the model, and we need to take the columns of it, right? And then we will going to plot it using the bar horizontal, bar h. I know this is a quite complex and messy code if you are watching it very first time, but let's just try to see what is happening. So let's start from here. What we are doing is we are creating, using the series, we are basically supplying two columns. This feature importances, which is this, and then the x variable for the plot function. So x and y is present, and it is basically producing the bar. pd.series is making sure that we have this basically properly arranged so that a plot function can work on this. So if I go ahead and execute, what will give you is an output where clearly density variable is going very high, type white or something not making any sense, so remove that. Alcohol is contributing, so first variable which is contributing high density, after that alcohol, after that residual sugar, after that you have free sulfur dioxide. So some 4 variables are contributing so high, so you can basically then go ahead and experiment whether keeping these 4 variables actually makes sense or not, and producing the same or the better output. If it is producing same and better output, there is no point where you want to keep the other variables, because it will simplify the model, also increase the performance. Okay, so that's why this output is very, very important, what I can see. Now, another last important part is, let's say you are designing an application and you want to accept a user input, right? So user input will be in the form of, like, they need to give, let's say, what is the wine type is, white or zero, or what is the fixed acidity, this. They will not going to provide you the total sulfur dioxide. So that type of thing, you will not going to get it. So how you can basically take an input and basically get the prediction out. So what I'm going to do is I will going to simply take any observation, like over here that we have, for example, this variable quality is 6. So technically the prediction should be 0, right? So let's say we do a testing, pred underscore test. Pred underscore test is nothing but wine.iloc, which will give us the second row here. Using the iloc method, we take the second index, and I will show you what it is giving you. So type is white, 8.1 is fixed at it, 8.1, 0.28, 0.28, so on and so forth. So nothing but we are taking the second row. Let's just assume that this is what user is basically providing. So what type of processing we may need to do to make sure that our system is giving you the output. So once you have done this, first thing first, we need to convert this white into 1, right? Because if you remember the dummy variable, so that's something, a programming which needs to be done. And second thing is we don't need total sulfur dioxide. Okay, so the way we will going to write that program in the backend, obviously with the help of if condition, that if type is white then 1, else red, but I'm just showing you here quick way. Sorry, type equals to 1, and over here you have we need to drop pred underscore test dot drop. What we need to drop is basically your basically 2 variables we need to drop. One is quality, because quality is y variable, and total sulfur dioxide, So I will write quality and I will write total sulfur dioxide. Okay, so once you have this total sulfur dioxide, and we will just have to make sure we are saying in place equals to true. Okay, now if I show you what is the output, is exactly the same what we are doing. So we now have type as 1, right? And now we don't have quality, which was earlier here at total sulfur dioxide. Because if you remember, total sulfur dioxide was having the high correlation, so we removed it, and quality is nothing but the y variable. So 6, so if you remember, anything above 7 is 1 and below that is 0. So ideally, the output of this should be 0. Okay, so now once we have this, what we need to do is we need to transform this like the same way we have done the x variable, if you remember, where we run the standard scalar and we just transform the data to make sure that the high values are not influencing the lower values. So if I go down, so remember this pred underscore test, okay, and if I go to the place where, so this is all what need to be combined. I'm just showing you in bits and pieces so that you get an entire idea as to how this needs to be done. So I created another cell and I will say scalar dot standard scalar is already been done. So I will say scalar dot fit, and fit what? We need to basically apply, we can't basically say pred underscore test. Let me just show you what will happen if we say that. So it will run an error and it will basically give you an indication that you need to reshape this, because what we are providing is only one-dimensional array, right? And using the reshape method -1, 1 or 1, -1, like this one, what it does is, along with the one dimension, it basically tells the machine that whatever output you are expecting, just reshape the data based on that. That means automatically take the do the changes that you need as per your requirements. So what I need to do is I will basically have to say then, so this is a sort of a program you may need to write, you will have to write when you are producing it in the front end. np.asArray, and here we will going to say pred underscore test, and using the reshape method 1, -1 is something will going to help this. Now this method will going to run fine, scalar.fit pred test, and we will going to transform as well pred underscore test underscore standard is scalar dot transform and pred underscore test. So once we execute this, you will see that now we don't have any error, and since we don't have any error now, we can basically get the output. We have this model already there, ypred. I will now say create one more this cell, and we will pass on this ypred test. So we say ypred test output is equals to logreg dot predict pred test std standard. This is the object that we created, right? And give us the output. So it should give us 0 because the quality was 6 and anything below 7 was 0. Pred test output. If I execute, here we get our answer, which is 0. So this is something an application output will be coming that you need to print or you need to show it to your user once they are entering these relevant variables, right? So think like this, that they are entering all of this. For white they are entering 1, or if they are entering white, then you are converting it to a 1. So up to you, how do you do that? But they are accepting all of these values from white till 10.1, but not the sulfur dioxide. So these are the values that they are inputting, and with all the processing we have done, you have basically telling them, hey, this is not the standard, this is not a good quality, right, based on this output. So after you have done, you basically do the scaling of the data, then you just run it, the algorithm. So that in the final, you will going to give the output back to them. This is what we are doing here manually, but you can write an application based on Python, like using Django or using Flask, using Dash, so that you can deploy your model and it's working in a production and quickly giving the output daily without much of an hassle. And think about this. It's like when machine is doing job, then why would you need actual bodies to do the job? So that way you will basically allow the companies to automate this entire job with the help of this program, and give them basically more savings in terms of what they are already spending. So yeah, that's mainly I wanted to show you this complete end-to-end project as to finally how the output will be given to them. And I hope you have enjoyed this session with me. Let me know how did you find it, and I will meet you now in the next video with a new topic.